Καλησπέρα σε όλες και όλους που βρίσκεστε
Good
εδώ.
afternoon to everyone, and thank you for the hospitality.
Εγώ ονομάζομαι Χριστός Παύλου.
My name is
Δουλεύω
Christos
για τη Hewlett Packard
Pavlou,
Enterprise
an employee of Hewlett
σαν
Packard
product
Enterprise
manager
Global, as senior
Global
product
R&D
manager in the Global R&D
έδρα
department,
την Ελλάδα και την Αθήνα.
which is based in Greece and
Σήμερα
Athens
έχουμε
specifically.
ακούσει κάποιες πολύ ωραίες ομιλίες για
We have heard many interesting presentations today regarding the applications of AI and machine learning.
Έχουμε αρχίσει και ακούμε σιγά σιγά πράγματα όπως
And we have also started hearing about issues such as infrastructure, environments, frameworks, etc. So I think this is a great opportunity to generally look into the nature of AI as an environment. It is a hybrid environment by nature, in the sense that edge locations have arisen as a result, and also to look at how we can have a hybrid environment with AI and ML applications running seamlessly from the edge to the cloud.
Καταρχάς, να ξεκινήσουμε με κάποιες κοινές παραδοχές. Τα
So,
δεδομένα
let's start with
είναι
some
μια κοινή
basic
αποδοχή ότι είναι
facts.
η κινητήριος δύναμη
Data, as we all
για
agree,
να αναπτύξουμε τα επιχειρησιακά
are the
μοντέλα
driving
της νέας
force
γενιάς.
for developing the operating models of the new generation, and this either has to do with offering our users better experience or with the speed of decision making, which is something very important, particularly in our day and age. It's also related to how we can get a better insight from the data itself. Very often we have data sitting on our cloud and our data center without having the opportunity to export information from it. So this may seem okay, and
Συγγνώμη, εδώ πέρα, ωραία. Thank you. Να μετασχηματίσουμε
we all may be interested in transforming our companies according to data-driven rationale. And that's usually what most CEOs globally wish for. But only 1/4 of companies actually do so, which means that there are problems. Right now, there's a huge gap observed where 10% of companies have the possibility of producing 2 or 3 times a higher revenue growth compared to the competition. And this gap seems quite dangerous as a result, because there are companies now lagging behind and others that have really sprinted ahead.
Πάμε να δούμε τώρα τους πιο βασικούς λόγους για τους οποίους οι
So what
εταιρείες
are
δεν μπορούν να πάνε
the top concerns we hear from global leaders regarding their future data? Why they can't move to data-driven rationale? One of the reasons is the data itself, which may be complex, distributed in different locations, which may be found in different systems, legacy systems in some cases. Also, there are different infrastructures such as edge, cloud, data centers, which means that it's difficult to manage all the data together. Also, sometimes we have silo environments where we have groups working in isolation from other businesses, which means that this does not allow us to exploit all our data. And of course, there's the issue of cost in relation to the relevant infrastructure. For example, in order to have a model based on GPUs or to use the cloud, the cost can be very high. For example, for situations such as data movement. We spoke earlier about hybrid environments. Well, according to an IBC report, by 2025, 55% of G2000 will adopt hybrid cloud platforms. The nature of AI and machine learning is such. Why? Because the term edge has entered our lives. It may have to do with a camera, a car, it may be an MRI machine, a server in a diagnostic center or a hospital where we retain local data. And there, of course, servers may be smaller. There are also data centers that can be used in order to train our models using very expensive equipment, and the cloud, which is very important in all this equation because it's very important for inference, for burst purposes, and also some companies choose to use it for training, etc. A very important example of a hybrid environment and how it operates in a real case scenario is the one used by one of our partners, Mercedes-Benz. They collect data from cameras and sensors. The data is sent to a central data center where training takes place. They use the cloud for outburst purposes, and there is generally a scattering of data, since we are talking about cars being driven around the world. Nevertheless, the company has managed to unify its system through our help. So, some of the data challenges that we have mentioned has to do with scattered data, different formatted data. There's also the problem of security. How can we ensure that our data will be secure, private? How can the data be moved from one location to the next without a leak or fraud or hacking? How can we ensure privacy of data that is by nature confidential, for example, medical data that cannot be published, of course? Then there are issues such as the following. We have the GDPR in Europe, which sets its own rules and regulations, which we need to adhere to, of course, and to make systems that adhere to it as well. And another problem affecting data management for many years has to do with backups, not losing data, machine learning, and having a correct reduplication so that we don't have the same data maintained 2 or 3 or 4 times, increasing thus the cost and the complexity of our infrastructure, since we're talking about training on large data in machine learning. Similarly, there are also problems with regard to the tools that we use for machine learning. For example, each tool may require a different input, different data management. Also, we see different groups use different tools, which means that at the end of the day, we have isolated environments whose data cannot be used, and this prohibits us from using all our data and all our know-how within a company. So, whether we choose to opt for solutions which are proprietary, that may mean that we are connected to a specific provider and we use specific tools which cannot be of help with regard to the cloud and the data center. This is a problem that can hugely delay the application and model development for our company. A very important statistical figure and fact is the fact that a large percentage of our data lose their value possibly after a few days, weeks or months. So their life cycle, their utility is not extensive. So the slower the model development in artificial intelligence, the larger the delay and the larger inutility of our data as a result, which means that 60% of models actually never reach the production stage. In this case, for the AI sector, it's important to note that there is a crossroads that we need to address, and those working in ML need to understand this. We are not no longer speaking about academic projects and models that may or may not work. We are speaking about businesses, actual businesses, who need these models in order to cover essential requirements. In the past, DevOps used to be a crossroads that many businesses came up against. Well, now we need to think about MLOps and how we can use this to obtain all our data and have a pipeline that will offer pre-processing, data preparation, training of models, model monitoring, and relevant mechanisms that can monitor the performance of models so that we can observe whether some models are not working well, how we can add data and do retraining in order to reintroduce into the system, etc. These are all very important aspects that we need to keep in mind when working with AI and ML. So, should you require any further information regarding these issues, we are at your disposal to discuss these issues with you. In the field of analytics and AI, the usual solutions were to use a cloud in general or use our own tools. But these decisions often come up against certain drawbacks. Using the cloud, of course, can be something effective. There's a low cost. You ask for a GPU, you get it. The capability increases, but the cost at some point in time increases due to the data movement, for example. And then you are trapped with a specific provider. On the other hand, the do-it-yourself solution using open source tools may sound good and well. The tools are usually free. You use cutting-edge technologies, but nevertheless, you don't cover issues such as enterprise security and data support, which are issues that you cannot resolve out of the box. So what we are suggesting is to embrace open source tools, since we're talking about ecosystems which are supported by enormous companies such as Google, Amazon, Facebook, and Microsoft, for example. If you look at the diagram, there are some tools which are now in decline, but others whose popularity is steadily increasing, such as Qflow, MLflow, which are being supported by many companies and have a large number of contributors, thousands of contributions on a weekly basis. So these tools are globally very popular and are used by many users. They can be applied from the data center to the cloud edge. So these are tools that can help us with regard to interoperability and being able to use all tools in all cases, the same tools in all cases. Companies looking into hiring new personnel, and these talented people are in Greece, are people who use these tools potentially in their PhD thesis or in their studies, which means that they are already trained and don't need a lot of onboarding time in order to start work. Open source software, nevertheless, also presents, as we said, many challenges with regard to enterprise security, support, integration. So what we answer to this is that we are able, by building on open source software, to provide a platform which is not simply based on one tool, but offers all this OSS and then builds on it further services for monitoring, observability, enterprise security, in order to resolve the data management issues that we spoke about earlier. And this offers all the advantages of the OSS by combining the benefits of these two worlds. one other very important issue before looking at certain case studies has to do with the fact that HPE right now has the strongest supercomputer in the world, the Frontier, as it is known, which calculates faster than the four next supercomputers that exist globally. You can look it up. So, based on the hardware technology and AI, we offer the opportunity of large language models so that you can use hyperparameter tuning for training by using HPE infrastructure and to obtain all this as a service. Now, let's look at two very important case studies. Some speakers earlier mentioned responsible AI, ethics, and the social impact. This is a very interesting case from India. It may seem a bit terrifying at the onset because it has to do with citizen identification using fingerprints. India is a country of 4 billion people. I think it has the largest population globally at the moment, 640 regions, 42 official languages, and also it has a benefit scheme of about 40-50 billion, and there were many people who did not have access to this benefit scheme because there were many people who lived on the street and had no personal documents, or they didn't have a phone or access to a bank account, for example, and could not benefit from this scheme. And on top of that, there was also fraud being conducted where people forged papers in order to get benefits, excluding others from these benefits. So, the government decided to use a system that would identify people based on biometrics. Together with HPE, the largest biometric database in the world was created, which includes about 20 billion biometric data. There were many problems, of course, that needed to be resolved. In the end, a system was established with 8 data centers across India, looking at how data can be transferred, how we can use a DR strategy where data is never lost, also how we can ensure that the system is always up, so that people can be identified at any time. There needed to be a rolling upgrade as a result, so that the system was always available. At the end of the day, the government of India was able to do all this with our help, and now uses some AI models that cover fraud detection and also speed up biometric identification. Because, of course, you cannot run through the whole database each time you want to match up data. So we use models that speed up these processes. As a result, the number of people who have access to these benefits has increased, and fraud has decreased, which means that the budget has decreased, I think, from 50 to 40 billion. So, less money being spent by the government, but benefits given to more people. Right now, 1.5 billion people have enrolled in the program, and there's an open dashboard offered by the Indian government showing the number of identifications, authentications, the number of enrollments.
Εντάξει, ο ρυθμός που αυξάνεται το enrollment αυτή τη στιγμή έχει πέσει λίγο, γιατί
enrollment has dropped a little right now because the population is 1.4 billion, so we're near the target. But what is important to note is that usually we have a very large volume of data that is constantly changing. And that's where retraining kicks in and how important it is to have a very large volume of data that can be retrained when it becomes obsolete and reintroduced. Another case study is one of my favorites and has to do with the applications in the health sector. Carestream is our partner, which is a company that works in the field of imaging. And they wanted to see how they could reduce the noise from the use of X-ray machines. It operates in 140 countries. Using hundreds of thousands of pieces of equipment. And we know how important all these applications are with regard to data privacy and following local rules. This is confidential medical data, as you understand. I cannot have an X-ray done in Thessaloniki, for example, and then see that this is X-ray is being used in a data set for training in China. This is a very serious problem because we're talking about personal data that must remain confidential.
Τα προσωπικά δεδομένα, πώς μπορούμε να κάνουμε retraining. Υπάρχει μια πολύ ωραία εφαρμογή στην
There's a very interesting application in Carestream that uses data for retraining. We have another service platform being used in Carestream provided by HPE. They're the imaging centers, hospitals. These are all using this technology. So what was the precise problem that this company wanted to resolve with regards to X-rays and noise? When we take an X-ray, depending on the level of radiation used, the noise increases or decreases accordingly. So large level of radiation, high level of noise, and vice versa. Since we do not, of course, want to expose patients to a high level of radiation, there's a rule of thumb that says that a good X-ray also goes with some level of noise, which means that the patient wasn't exposed to a high level of radiation and we got the results we wanted. But what if we have a baby, for example, that has problems with muscles or its spine that has to repeatedly undergo X-rays? In this case, we want to develop models that will allow us to have an X-ray with high or low noise and use models that can improve diagnosis, reduce radiation and noise at the same time. Carestream has been able to use this application and it's has observed that when we have a low exposure of radiation, the noise has now reduced by 4 times, by 2 times when we have a higher level of radiation, which means that the results have been improved and the patients have been exposed to less radiation. So we said previously how important it is for data to be retained locally. In such cases, for example, we're talking about medical imaging. There's a term known as federated training that we have implemented together with Carestream. And what is it? It's a model that we have trained using some data that is either masked or there is public also data based on X-rays that can be used to train a model. This model is then used in all edge locations. Then and new data is collected, which can be used for retraining. However, you cannot send data back. So federated learning is the following. You have a retraining of the model on edge, and instead of sending data back for central retraining, you do the retraining locally, you get the new parameters for this model, you send this back to the central point, so there's no data exchange. You simply obtain parameters for the new model and send this back to the central point. And by collecting deltas from 140 countries, the central point creates a new model that is then tested and is then introduced to production and sent to the various locations. To conclude, I would like to say that all that we have spoken about is also available in Greece, not only the products, but also through the establishment of a center of excellence that we have in Athens and is run by me and a colleague. Maybe you've read about it in the press. It's a recent development. We are a group of 30 engineers. In the past, we have collaborated with many of you, and we have really struggled with AI applications with regard to MLOps and how we get this cycle from data collection, preparation to training, monitoring, and retraining. Our company wishes to invest in this field, in the Center of Excellence. It is actually the third technology hub that Hewlett-Packard Enterprise is establishing globally after America and India. So Greece is fast becoming a pole of interest. As was mentioned by previous speakers, there are many highly qualified, talented people in Greece, and companies must invest in this. People who want to stay in Greece to work, to offer their services. And this investment being made by HPE is extremely interesting indeed and significant. Already we have 30 young engineers working there, and we want to expand this department covering from AI to MLOps. We are delighted to be here and to be able to help Greek businesses take the next step forward with regard to their digital transformation. That is all. Thank you very much for giving me this time. I wish you all the best, and of course, if there are any questions, either now or later, I'm at your disposal.